Hello, welcome back. We're going to talk about the intermediate value theorem and how to solve some problems. So this is an extension of the lesson, or if you just want to know how to do intermediate value theorem and what it all means. Well, intermediate value theorem, and here's the definition. I'm going to write this down, but it says it has to be for continuous and closed interval functions. Okay, and what we're going to do, this is an existence theorem. If you're not sure what an existence theorem is, an existence theorem, just have that where I go. Existence theorem is where we try to determine where a function or where a special case would exist. Okay, so this isn't telling us what the value is. It's just telling us if something exists there. So what we're trying to find out is, we're stated in here is that if a function is continuous on a closed interval, what we're saying is that f of a, if it's not equal to f of b, then there's a k value. All right, this is going to be a y value. It can be any number between f of a and f of b. So these are two other y values. All right, so there's going to be a k value. Then there is also at least one number c on the interval such that f of c equals k. So what we're saying is that there is going to be some sort of c value that's going to equal k. So, what does that mean? Well, right here, we went through an example in my previous class when we had this, but we're going to go through two examples and kind of explain what this is. So we're going to explain why a function has a 0 on the given interval. So here's an example. So we have a function g of t equals t cubed plus 2t minus 2 natural log of t squared plus 4 from 0 to 1. Now, what we're saying is that explain why the function has a 0 there. So we're trying to find a 0. That means an x-intercept. Okay, so that means an x-intercept. We're looking for an x-intercept here. All right, intercept. All right, on our graph. Now, to verify this, we're going to use the intermediate value theorem to help us verify this. All right, intermediate value theorem is IVT. All right, IVT, not IVI. All right, and so what we have is we're going to verify the function first, that the verified function is continuous. Because if it's continuous, then we know that one point will have to connect to the other point. There's no holes, no gaps, no breaks in the curve. No breaks in the curve. So on this closed interval, and at the endpoints are not equal. So right here, we are going to find out what this is. So is this continuous? Well, yes, this function is continuous because there are no breaks here on this curve. This is a polynomial function. This is a natural log function. This cannot be 0, so any value can be here. Right here, natural log, this will never be 0 or have any values that are going to be negative. So this one is also continuous. So this is continuous, especially on 0 to 1. All right, 0 to 1. We have values on all the values between 0 and 1. So we are good here. So we would say that g of t is continuous. All right, on the interval. All right, from 0 to 1. Okay, so 0 to 1. Nicer. All right, on the interval from 0 to 1. Now, on the interval from 0 to 1. So once we state that, now we're going to just make sure that our values are not equal. So we're going to plug in g of 0. All right, and we're going to plug in g of 1 and find out what those values are. When we plug in g of 0, we have 0, 0, negative 2. So we have negative 2 here. All right, and that's going to be times natural log of 0, natural log of 4, it appears. Okay, so here we have a negative value. Natural log of 4 is a number, times negative 2 is going to be a negative number. So that definitely, all right, isn't 0, but we have that. Next, we're going to plug in 1. Plug in 1, we have 1 plus 2 minus 2, so it's going to equal 1. All right, times natural log of 1, so it'll be natural log of 5. All right, natural log of 5, which would just be natural log of 5. Are these values equal? No, they are not equal. So now, next step is this. Find the values of the endpoints. Well, we verified that they're not equal, so we did find the values of the endpoints. All right, step 2. So if we didn't do that, we want to do that. All right, so if you even skip that one step and do this one, just verify that they're not equal. All right, and so what do we just conclude? So now we're going to find our conclusion. Well, if this function is continuous on this closed interval from 0 to 1, and we verify that we found g of 0 and g of 1, all right, and this goes from negative to positive. So what does that mean? That means that this value, if you think about this, at 0, okay, we have a value that's negative 2 natural log of 4. I don't know what that is. It's going to be up here, or actually down here somewhere. All right, negative 2 something. All right, let's just say that's negative 2 natural log of 4 right there. We'll just put our point there. The other one is g of 1. All right, so at 1, we found a value of natural log of 5. Natural log of 5 is probably going to be Probably right here. We'll just put like right there. We'll just say this natural log of 5. I'm not sure what it is, but I'll put my point right there. And so what happens is that since this is continuous, I know it's not a straight line, but I know that this value is going to go from here to here. They will connect because it's continuous. They have to connect somewhere here. It might go up and down, but we have that. So we are trying to figure out, do we have a 0? Does this intercept the x-axis? The answer is, well, yes, it has to intercept the x-axis, and it will intersect at least once on the interval from 0 to 1. On the interval from 0 to 1. And so right here, we can make our conclusion, all right, right there, is that we can conclude that, yes, all right, G has a 0, all right, on the interval, all right, 0 interval from, let's go 0 to 1, all right, because of IVT, intermediate value theorem, all right, and if we want to put in here, because we know, all right, right there, 0, all right, because of IVT, and what does that say? Because right here, we know that G of 0 is negative, and therefore that's going to be less than some sort of value, all right, G of C, all right, G of C, because we know that's going to equal, G of C has to be equal 0 somewhere, and we know this one is actually equal to -2 natural log of 4, all right, which is going to be less than 0, and we know that right there is going to be less than G of 1, somewhere right there, all right, and we know that's going to be natural log of 5. All right, so there has to be some sort of C value on this interval that will generate a 0 because we know that this function is continuous, and according to intermediate value theorem, it's going to be a C value on the interval from 0 to 1 because we go from a negative value to a positive value on this interval. All right, so that's our conclusion. That's what we got. All right. Let's try one more, okay, one more. This is number 99. So what we're going to do here is we're going to verify that the intermediate value theorem applies in the equivalent interval and find the value of G that's guaranteed by this theorem. So we're going to apply this. So essentially we're going to go through and make sure that in this case, we're not finding a 0, but we're finding a value of 11. So we're going to verify that we have a value of 11. So to do this, we're going to go through the same thing. So intermediate value theorem is going to guarantee. So we're assuming that if we plug this in, and we have to first say this is continuous. All right, well, the f of x is continuous, all right, is continuous on this interval from 0 to 5, okay, so on this closed interval from 0 to 5, it's continuous because it's a parabola, it doesn't have any breaks in the graph, there's no undefined values, nothing in the denominator. Okay, so we verified that. We can verify that it's not equal, all right, so let's find out those values. So I'm just going to find that because that's our second find the values of the endpoints. So I'm going to plug in f of 0, which is going to equal -1. All right, I'm going to find f of 5. All right, plug that in there. And we have that. We have 25 plus 5 minus 1. And what we have there is going to be 30, 29. Well, this is the question. All right, is 11 between -1 and 29? Well, yes, it is. So there should be an f of c value, which equals 11, which is going to be between f of 0, which we know is equal to -1. All right. And this value right here, f of 5, which we also know equals 29. All right. If I want to move this over a little bit, all right, and actually move that up there. Oops. All right. Move that over there. All right. And so that's what we have. Okay. We found out, all right, that the intermediate value theorem does work out. There is such values. And so now it's saying in our conclusion, we know we have just verified the intermediate value theorem works by stating it's continuous. We found these values. We found that f of c, which is equal to 11, is between these values. So we know there is a c value. The next thing is find conclusion. In this case, is that we want to find the c value to guarantee this. So essentially now, we're going to be taking our function right here, and we're going to actually solve for, find out where does it equal 11. That's what we're trying to figure out. When does it equal 11 in this case? So we're going to take this and set it equal, all right, to 11. And we're going to put in c in here. So c squared, so we're trying to find a c value, all right, -1, and send that equal to 11. That's what we're trying to find. What are the c values that will equal 11? So now from here, it's going to be f of c. All right. So from here, we're going to now use algebra and solve. So we're going to subtract 11 to the other side. So we have c squared plus c minus 12. And now that will equal 0. The reason why I'm going to do that is because I can factor this, hopefully. Yep. All right, c plus 4. All right, c minus 3. PO. Ha ha ha. Laugh. All right. And then what we have right here is that c can equal -4 and c equals 3. And at these different values, so when f of -4 is plugged into there, that's going to equal 11. And also when f of 3 is plugged in there, it equals 11. However, check out our interval. We're looking at only values between 0 and 5. Only values between 0 and 5. And so which ones are not going to be used? So check the interval. Check interval. All right. We are guaranteed that this one works. All right, that's the one we're going to guarantee. And even though we have two values, but between 0 and 5, all right, 3 falls in that. And we just verified, yes, there is a C value. That value is 3, and that will equal 11. So that one, no worko, and that's our only answer. All right, there we go. That is how we use the intermediate value theorem. All right, it's used to essentially show that there's the existence of a value. All right, existence of a value. All right, on an interval. And 3 different steps. Show that it's continuous first, so you know there's not going to be any holes or gaps, so you know it's going to connect. Next thing is verify the value. Make sure that the value is between both the endpoints, and if it's between both the endpoints, you know that it's guaranteed to have that value, and then we can write our conclusion, whatever they ask us to do. All right. So, hope this helps you understand the intermediate value theorem and how its application. All right. So good luck and God bless in the rest of your problems.